absolute value function, and it's 2 pages long, pages 6 and 7. And we're going to be talking about how can I transform other functions. So 2 weeks is a long time ago, but before the break, we transformed your quadratic equations, or your x squared, okay? And the transformation would mean you take the parent function and you would either move it right, left, up, down. You might make it, instead of opening up, you might make it open down. We learned how to make it wider or skinnier, okay? So that's what a transformation means, okay? So instead of doing it to the quadratic parent function, we're going to do it to the absolute value function, all right? So the first thing we're going to do is we're going to talk about the absolute value. Question 36 says the absolute value function. Consider the function machines below. For the function, f of x is equal to the absolute value of x. Absolute value just means you want the distance from 0. Distance is always measured in positive units. Okay? So if you plug in a negative number, that negative number, say it was negative 8, is going to be 8 units from 0, so it would be positive 8. But if you plugged in 9, which is already positive, it's still going to be 9 positive units. Okay, so the answer always comes out positive. So for the first function machine, if you plug in negative 9, you want the distance from 0, it's going to be 9 units. For the second function machine, you plug in a 7, it's 7 units from 0, so it's 7. For the third function machine, you plug in the radical of 2. You plug that into your calculator, you get like 1 point something. It's just a decimal. But that's just radical 2 units from 0. And then the fourth function machine is the opposite of the square root of 2. And it's, when you take the absolute value, it's going to be radical 2 units from 0, and it ends up being positive. Thank you. Bye. All right, part A says determine the missing inputs and outputs below. Make sure you state all of the possibilities. Okay, so this first row, they just showed us what happens with the input. Here's the output. Input, output, input, output, input, output. Okay, so for here, something's going to be missing, either the input or the output. So in the first one, input is missing, or that's where their question mark is at, and the output is 4, okay? They want to know what numbers could you put into this function machine to get an output of 4. There are actually 2 options. If you put in 4, you're going to get out 4 for your output, and if you put in negative 4, your output would also be 4. Does everybody understand that one? Yes. You have to list both of them in this case, yes. 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 All right, so for the second function machine, their input is negative 16, so the output is going to be positive 16. Okay, that's pretty self-explanatory. The third function machine is missing its input. The output is 9. So again, there are 2 numbers that you have to write that are going to be the input. That would be positive 9, would be 9 units from 0, and negative 9 would be 9 units from 0. Okay? Any questions on those 3? Because the last one is where you're going to get an interesting answer. So in the last one, the output is negative 3. That's not possible. There's nothing that is negative 3 units from 0, because distance is always measured in positive units. So you're just going to say there's no value that works for that one. All right? Part B says, if you are given an output for this machine, how can you figure out the input? The answer is, if the output is positive, the input could be either the positive or the negative of the output value. Okay? So someone asked, do we have to put both? Yes, the positive and the negative if you're looking for the input. Okay. All right, so that's how your absolute value works. For question number 37, they want us to make a complete graph of the function of y equals the absolute value of x, then fully describe that graph. Okay? So this is what we call the parent function of the absolute value. Right? So I just made a t-chart and took the absolute value of some numbers that are pretty common when you're graphing, starting around 0. So if you take the absolute value of 0, you just get 0. You take the absolute value of 1, you get 1. If you take the absolute value of 2, you get 2. If you take the absolute value of 3, you get 3. Those are all pretty self-explanatory, right? So now let's try the absolute values of some negative numbers. So if you plug in -1, your output is +1. If you put in -2, your output is +2. And if you put in -3, your output is +3. Okay? So this gives us some coordinate points, and if you start to plot them onto your coordinate plane, you're going to see that it makes this V-shaped figure. Okay? So -3, 3, you would go 3 to the left, up 3, put a point. -2, 2, you'd go 2 to the left, up 2, put a point. -1, 1, you'd go 1 to the left, up 1, put a point. 0, 0 is just right there, 0, 0. You don't move at all. 1, 1, 1 to the right, up 1, put a point. 2, 2, 2 to the right, up 2, put a point. 3, 3, 3 to the right, up 3, put a point. So I chose numbers to plug in between -3 and 3. But there's a ton of other numbers, including decimals and fractions, that are all in between these numbers, right? And larger than these numbers. So we're going to add this ray going to the left, put a little arrow on the end showing that it's going to keep going, right? We have a ton of more numbers in there, in what we would call infinite amount of numbers to the left and infinite amount of numbers to the right. We would say this is going to negative infinity and this is going to positive infinity, okay? Then they want us to describe this graph. Unlike the parabola, which is kind of U-shaped, like the letter U in the alphabet, this one is more V-shaped because it has that sharp turn down at the bottom. It's not smooth and kind of rounded like our other one was. This one is also going to have a line of symmetry, just like our quadratic did. Okay, we could match up the left to the right. It has, from the left side coming this way, it's decreasing. Then on the right, it's going to start increasing. Okay, it has a vertex at 0, 0, and that also happens to be the lowest point. So it does have a lot of similarities to our quadratic, right? It has a vertex, it's symmetrical, it's decreasing and then increasing. So it's kind of similar, but not exactly the same, okay? All right, any questions on page, does that say 6? 6. Anybody still writing? No, all right. Flip over to the top of page 7, where it has question 38 that says your transformation team challenge, okay? So in your teams of 4, as you did with parabolas, you're going to list all the types of transformations of the graph of y equals the absolute value of x. For each transformation you list, you're going to show the graph and its equation, then write the graphing form of the equation for the family of absolute value functions. Be prepared to explain your reasoning, okay? So, in your group of 4, you're going to do 3 graphs because there's A, B, and C, okay? So you're going to go to Desmos.com. You're going to type in the parent graph. Parent graph is the one we just did on the other page. Type in y equals the absolute value of x. If you can't find the absolute values, In the lower left-hand corner, you're going to open up that keyboard, and one of them will be your absolute values. And then after you've typed the parent function, then you're going to go to the next line, and you're going to type the parent function again, but then you're going to do some transformations to that parent function, okay? Something that's going to move your parent function left and right, up and down, moving it around in the coordinate plane. Make it open up, up. Have one of them open down. Make something wider or skinnier, okay? There are 1, 2, 3, 4, 5, 6, 7, 8 things listed here, okay? Between your 3 different graphs, you need to do these moves, all 8 of those moves. Does that make sense? Because you can do more than one on each of your transformed graphs, okay? I will leave that up there so that you can see